Kia ora. Here's our fourth example. Remember, we worked out it was a C3H7Cl and that it was a totally saturated molecule because there were no double bonds, and we have 3 carbon environments. So every carbon is in a different environment because we only have 3 carbons. And so we can draw this isomer, and you can see it's 3 carbon environments, or we could draw this one, but it actually only has 2 carbon environments because the ones in red have got exactly the same 4 groups on them. And so it can't be number 2, and there's actually no other isomer we can draw. So this is pretty easy, but we still need to explain in terms of our mass spec fragments. So let's have a look. Our base peak is 43, and which is a loss of a chlorine radical. So we could lose a chlorine radical over there or there and still get the same base peak. So that doesn't really help us. So there's our fragment for number 1 though. And remember, you must always draw your fragments to show your understanding. And otherwise, what we can do is we can look, okay, what would be suitable that we can see. I wouldn't go too far down, but there's one here at 49, and you can see that this has a chlorine in it. And here's another one that has a chlorine in it. So this would be a loss of a methyl group, okay? And from here to there would be a loss of an ethyl group. So I've lost an ethyl group. Now, notice number 2 could lose a methyl group, so it could also have this over here, but it won't ever have the loss of an ethyl group because I don't have an ethyl group possible in this compound. So that is a very strong indication that it has to be this first isomer and not the second isomer based on mass spec, even though our NMR shows you that it has to be the first one anyway. If we wanted to look at the mass spec for the second isomer, notice that you can see here we've lost our methyl as before, and we can't get a loss of an ethyl. We have just simply got the strong peak here at 43, where that chlorine has come off. All the best. Kia ora.